Hi everybody. Let me change this a little bit so we can see it. Welcome back to Chem 140. Let me wind the music away. So, I didn't actually update the announcement. I'm a little behind on what I wanted to do today because I took a nap after the previous class, and then the alarm went off, and I was like, what's going on? Why am I so awake? And then realized I had 5 minutes to go online to start the lecture, so. Where is my thing? So, oops, that's not right. Where is it? There it is. So, we are... review... Oops. Review... Session for exam number 2 and lab number 5. That's good enough. Okay. So, like I was going to say, like it says below, and then realized everything was wrong. We're going to talk about lab number 5 today, and then also do a review for exam number 2, provided anybody has any questions. When is the lab due? So it's due next week on Tuesday, and closes Wednesday. Wednesday, I believe, is the day of the finals, so don't get overwhelmed by things. I would work on the lab ahead of time, because it will be helpful practice for Unit 16 stuff, which is what we're going to do here real quick. So, let's start by diving right into lab worksheet number 5, which is a sort of practical way to apply the stuff that we learned in Unit 16. So we're going to look at two specific techniques. One is dilution, which we talked about, and then the other one is titration, which is basically the very last section that we covered in Unit 16, which was stoichiometry with solutions. Titration is a method by which we get all of the numbers to do that. And so you're going to see that in practice in here. So for the first section, we're going to talk about how to make a solution. And so we did this yesterday. This was the whole, I want to make a solution that is this molarity and this volume, but I only have this stock solution handy. What do I do? Write a prep for this. And so if we scroll down, you could read through all of this on your own time if you'd like. You'll see that we have the dilution equation. This version uses 1s and 2s as opposed to S's and D's, but it is the same thing. And then there's an explanation of all the variables here and how to do this. And then there's our few steps to prepare a solution. So remember that to make any solution, you just need to figure out how much solute or solvent you need. Move that into a flask and then fill that flask up to the line, and then cap the flask and invert for 60 seconds. Now, I've written here you want to invert at least 50 times. That's on the assumption that you're flipping it over roughly 1 time every second or so. If you're sitting there and just mixing for 60 seconds, you're going to probably hit 50 times anyway, so that's fine. Let's see here. So that's part A. I'm going to skip part B just for now so that we can see some data with part A. So we'll come back to this real quick. There's a Buret, whatever. Okay. Like all experiments, they're going to start with some questions. And it's just basically, did you read this? Can you define these things? And sure you can. All right. So in part A, you're going to have to make 2 solutions. One of the solutions is using solid sodium hydroxide. The other is using a aqueous solution of vinegar. Excuse me. Those are the 2 solutions that you're going to see used in questions 7 and 8. And I've run into an issue here. Where is my pen? There it is. All right. So how does this work? Let me scroll this up so I have somewhere to write. There we go. Oh, weird. I don't know why I did that. All right. So the first thing you're going to do is prepare a solution of sodium hydroxide. And so the molarity that you want is 0.200, and the volume that you want is 250 milliliters. I actually have too many sig figs there based on, oops, that's not the right command. So there we go. And there should be this dot right there. Remember that when we have a solid reagent, that if you take the molarity times the volume of what you want, you will get the number of moles of solute that are in the solution. And then it's just a matter of, okay, weigh out the solute, put it in the 250 milliliter flask, add enough water to hit the fill line, mix for 60 seconds, right? Now, the only issue that you can really run into here is that this is in milliliters. So we need to turn this into liters. And so I would get... actually, I want to write it like this. So there's my molarity. times my volume, which I'm going to write like this. And so whatever this ends up being, so 0.200 times 0.250 is 0.050. So I would need to have this many moles in the container. Well, what would that mass be? Well, I can just do this. Here's my mass, and then we'll just convert it from moles to grams. And I believe that NaOH is like 40 grams per mole, almost exactly. So I'm going to look that up on LenTap real quick. NaOH, 40.00 is what we got. And so we just multiply 0.05 times 40, and you get 2. So to prepare the solution in step 7, we've calculated how many grams of sodium hydroxide are needed. And so there it is right there. So now what you would need to do is tell me how to prepare the solution using that number. So I've shown you the answer. Now your job is to tell me how to make that solution with that number. So that's how you do the first one. Let's talk about how you do this next part right here. Oops, I'm clicked on the wrong thing. All right. For problem 8 in the lab, you're going to be doing this with a liquid. Now, the issue that you'll run into here is that the terminology is a little bit confusing. So we're going to prepare a solution with a quote-unquote dilution factor. So what is meant by a dilution factor? This is a terminology that we use to say, okay, I want my concentration to be by a factor of whatever. So if I had, let's suppose that my original solution had a molarity of 0.8261. So this is my original vinegar solution that we're going to use in part 8. But this is too concentrated for us to titrate with, because if I gave you this solution and then I said, okay, do the experiment, what you would end up actually doing is using up so much reactant that you'd have to fill your burette multiple times. And that's actually not practical, and it's also not good. You don't want to do that. We'll talk about that in just a second when we talk about part B. But the gist is we make you dilute the solution so that once you do titrate your diluted solution, then you will get a result that falls within 1 burette's worth of reactant. If you go over the amount of a burette's worth, then you have to fill it again, and that introduces error. So we're trying to get it so that you have to titrate somewhere within 1 burette, and a burette holds 50 milliliters of reactant. So you're going to titrate this sample that you're preparing with the sodium hydroxide from before later on. Or, I mean, in theory, you would. In the real lab, what we would have you do is you would actually go and make these solutions. So you'd make the solution you just prepared in 7, and then you'd make these solutions for step 8 based on which dilution factor I assigned you. Normally, I had these, like, ridiculous playing cards, and you would either draw a 3, a 5, a 7, or a 10. Let's look at an example if you drew a 3. So if your dilution factor was 3, then what you would do is you would take this number and divide it by 3. And so if we go over here, and I type it in the calculator, this is what I would get. So I would get 0.2754 moles per liter. So if your goal was to make a dilution factor 3 solution, you would take the original concentration and divide by 3. Now, if I gave you a 5, then you'd just replace this with a 5 and you'd get a new number. We're not going to do that because you're going to do that for your example or in the lab itself. But now that we know what a dilution factor is, we can talk about how to prepare a solution. Because when we are looking to make a dilution, we need to know this stuff, right? And I'm using 1 and 2 here, but you could replace this with S and D if you'd prefer. For the molarity part, we would say, okay, the original molarity, and then the diluted molarity would be the volume after we have done the dilution factor. Not the volume, I'm sorry, the molarity. And then how much of the solution do we want to prepare? Well, the directions tell us that we want to make 100 milliliters of solution. And so we would solve then for V1. And so if we plug in all those numbers, then we get this. So these would cancel out. And what I should get is, since this was 1/3 of the molarity, I should get 1/3 of the volume. I get 0.33333 liters. So, well, 0.0333. Or that many milliliters. So for a dilution factor 3 solution, what we ended up doing was we calculated the new expected molarity. So this would be the dilute molarity in red there, or pink. And then we solved the dilution equation to figure out what volume of stock solution we need to prep the solution. So to make the dilution factor 3 solution, you would add 33.34 milliliters of stock solution. I don't know what happened there. I think I'm going too fast for Photoshop. It needs to reboot. To a 100 ml flask. And then we'd add H2O to the mark. And then mix for 60 seconds. And then, of course, enjoy. All right, so I've shown you how to do part A for question number 8. You should be able to do B, C, and D now, where all you do is just change the number up here where we had dilution factor 3. You're going to turn that into a 5, a 7, or a 10. And that's going to affect this result that you get right here. Now, of particular interest to you, i.e. the one that you absolutely want to make sure you get correct and you don't make a mistake on, is this right here, number 5. The reason for this is because later on in the lab, in part B, you are going to use solution with dilution factor 5 as part of your titration. Okay, so we're going to come back to that. All right, let's talk about part B. I'm going to show you the picture of this Buret that doesn't fit on the screen, so we'll fill the screen real quick with it. That's not how we stretch the picture out. All right, this is what a Buret looks like. A Buret is a long cylindrical tube that you attach to like a little grabby claw arm and rests vertically over a flask that you're going to be working with. In 163 and probably 160, well, actually all of the 160 series, really, this is the most common piece of glassware we use for analytical work. What this means is that we're going to give you tasks that require you to determine a very specific volume of a reaction to understand the amount or quantity of something that you are working with. And yes, that is the scientific name, the grabby claw arm. Now, it's real unfortunate that we don't actually get to work with a Buret. So you can look up online like how to use a Buret or titration of acid and base or whatever, which is what you're going to be doing here if you would like to. I don't know if I actually link a video here. Let me see if I do. I might actually in like part B. I don't see one. Okay. I realize this is scrolling super quickly, but okay. The titration that you're going to be doing is an acid-base titration. And what that means is that you're going to react an acid being something that makes this, H+. You're going to react it with a base. A base is something that removes that H+. Typically, a hydroxide does that because hydroxide plus H+ will make water. And I have that reaction right here. So mixing an acid with a base will make water, and then whatever's left over is the salt that is formed. The reactions you're going to do here, here's the reaction for sulfuric acid with sodium hydroxide. The sodium hydroxide is going to be a solution that you have prepared in question 7. So you know its molarity. You just need to figure out how much of it you will use. That's going to react with sulfuric acid. We're going to give you an amount of sulfuric acid, and you're going to calculate something about it, or something about the sodium hydroxide. I forget which one. I think we're actually figuring out. I'm trying to think of it off the top of my head. I don't actually remember. We'll look at it down there when we get to it. But if you know the molarity and volume of one of these two solutions, then by figuring out the volume of the other solution that is used in the experiment, you can get the molarity. So let's draw a picture of that really quickly. Actually, you know what? Let me just find out which one you were doing. We give you the molarity of that. Okay. Okay. So let's describe what you're doing in part B. In part B, the first part of part B, I should say, you're going to react sodium hydroxide with sulfuric acid. The reaction for that is shown at the top of the screen there. You can see that. And here's what that's going to look like visually. So here's my Buret, which I realize looks like a giant pencil. That's okay. It's got a little doohickey that allows liquid to flow out, and then it flows into this flask here, which has a solution in it. You're going to put the sodium hydroxide in the Buret, and then pour that into the sulfuric acid down at the bottom. For the first part, again, part B, number 1, the amount of sulfuric acid that you use is known, so its volume is known, and its molarity is known. And remember that if you know the molarity and the volume, you know the number of moles. Now, if you know the number of moles of sulfuric acid, well, I'm going to put a little X here. Then, by using the balanced chemical equation up here, you can then do something like this, right? Because for every mole of sulfuric acid that's in there, you would need 2 moles to titrate it. And that would tell you the number of moles of sodium hydroxide that would be used in this reaction. So, you know these two numbers, so you're going to automatically know how many moles of sodium hydroxide are needed to finish the reaction. And then when we go back over here, if the moles of sodium hydroxide are known, then the molarity and the volume multiplied together must equal that, right? The volume is known because when you do the reaction, this will drain down and you will get the volume of sodium hydroxide this way. So that number is going to be in a data table. If you know the volume of sodium hydroxide and you know how many moles it is, you could say moles divided by volume equals molarity. And then you can solve for the molarity of the sodium hydroxide. Now, in part A, you actually figured out what the molarity of sodium hydroxide was because we determined that, right? So up here, this is part A. I'm scrolling all the way back. Problem 7. We said, well, wait a second, I want this molarity for my sodium hydroxide, right? What you are doing in part B, is you are verifying that you are going to get that number. Because when you use sodium hydroxide pellets to make a solution, they come in these big chunks. And you have very little accuracy because it's very hard to weigh them out. Each pellet weighs like 10 or 15 milligrams. And you want to get down to like maybe 0.1 milligrams. It's not easy for you to cut these pellets into pieces. You can't really get shavings of them. There's not really much you can do other than just grab a bunch of pellets and get as close as you can. So the number that we assume for part A, problem 7, is not going to be very accurate. So the point of the first part of part B is to figure out accurately what is the molarity of your sodium hydroxide. You could smash it with the hammer, but the sodium hydroxide is very, very reactive, and it would corrode whatever you're using it on. Also, then you got to pick up all the pieces, and they're corrosive too, and that's no good. So it's easier to just assume, like, okay, my number is going to be close to 0.2. So we'll just hope for the best. But this is what you're doing with your titration. So let's now go to the data table for part 7. Not part 7, I'm sorry. Part B. And see if it matches our number from question 7. Okay, there's our data table. So what we're going to be working through, we're actually going to be doing like questions 11 through 13. Oh, excuse me. All right, so we're going to scroll this up. Oh, I'm at the bottom of the document. Hold on, let me make this bigger. Canvas size. I want the canvas to anchor there. And I want it to be 200% tall. Sorry, give me just a second here. Boop. All right. I now have this ginormous document that's going to slow my computer down inevitably, but that's okay. All right. So what we're going to do is we're going to figure out the number of moles of H2SO4. And so we need the molarity and the volume for that. Those numbers are given in this data table. So I'm going to use 25 milliliters of volume and 0.0750 molar H2SO4. So the amount of sulfuric acid used in our trial would be this. And I only get 3 sig figs, so I have to write 0.00188 moles of sulfuric acid. All right. Then, once we know the number of moles of sulfuric acid here, I can then do stoichiometry, because remember the balanced chemical equation was, we wrote this up here, for every 1 mole of sulfuric acid, we would also react 2 moles of sodium hydroxide. So let's do that down here. So and again, that's from the balanced equation that we showed way at the start of the document. So we just take this number and times it by 2. Actually, I guess if I put in 0.188, it would be 0.00376. So I'll write that down. That's fine if you wrote 375. So that's how many moles of sodium hydroxide are in this sample, or that are needed to titrate this sample, I should say. Now, we are using 3 separate titrations. So the first attempt, we started with this volume and we ended here. So this is trial 1. Trial 2, we did these 2, and then trial 3, we did these 2. So to figure out what the volume is that we used, we would say, so if I go back up here to my Buret here, if I was looking at trial 1, and so I started at 0.20 milliliters, and then I ended at 15.78, then the volume used would be the final volume minus wherever I started, right? So this would be 15.78 minus 0.20, which would be that. So there's the volume that was used for trial 1. You just subtract the 2. So we know the volume now, so we can figure out the molarity. Because this is the number of moles that I have, right? So if M times V equals moles, then moles... Ooh, that's weird. That's not how that's supposed to work. I think the backdrop got changed to black there. Oops. So I'll just do this. That's good enough. Then moles divided by volume would be molarity. And we have both of these numbers, so let's just do that. So I've got that many moles of sodium hydroxide, and then I calculated this was our volume. Remember, volume has to be in liters, or else the calculation doesn't work. Then what you get isn't moles per liter. And when we do this calculation, we should get real close to 0.25. Was it 0.200 or 0.250? 0.2, I think it's 0.200. And you'll notice that we're kind of a little off here, which shows that it is actually very difficult to make these solutions accurately. So for trial 1, we calculated that based on the titration that we did, this is the molarity of the solution we had. So now what you can do is you can do trial 2 and trial 3 and see how close you get. Noting that the only thing that changes for each volume of the trial is this, because this is the volume of NaOH that was used, right? So that's going to matter what you calculate in the data table. Alternatively, what you can do is that you can figure out what all the volumes are for each trial. And because, again, that's the only number that you really are changing is this one I've circled here. You can then plug in the average volume and get a result there. Now, in the documentation here, it's going to ask you calculate for each titration. I'm saying for each titration over and over and over again because I want you to specifically understand which ones are the same and which ones are different. So if you say, well, duh, I use the same molarity and the same volume of sulfuric acid, so it's always going to be that number we calculated, that 0.00188, then that's exactly correct. That's what I want you to say. Okay. All right. So that's part B, number 1, for up through question 14. There is an issue with the document, so be very careful. There's supposed to be a line break right here. So this question right here, there should be a carriage return. And this right here belongs to questions 15 and beyond. Okay. So question 14 would be calculate the percent error. Well, you're supposed to have 0.2, right? We got 0.241. Can you calculate a percent error? Yes, you can. I'll leave that for you to do. For question 15, you're going to use the solution from before where I said it was dilution factor 5. You remember that, right? So if I scroll all the way back up here, this solution. Now what you're going to do is you're going to use your result for the sulfuric acid that you calculated, and you're going to titrate the solution with dilution factor 5, and that's going to be part C. Not part C, I'm sorry. Part B, number 2, I guess we'll call it. And I give you data for that. And now the goal is to figure out this. Because if we go up to our little... Oops, that's not the thing I wanted to scroll. If we go up to this titration here, I can't really fit all of this on the screen super well. Okay. Now what we're going to do is we're going to say, okay, I'm not going to be able to draw over this because I can't... Oh, no, wait, I can erase up here. This will be okay. I just can't erase down below. You know, it's probably easier if I just do it this way. All right, so for part 2 of part B, you know this information. We know what volume is used, that's 25 milliliters, but we don't know the molarity of it. We've diluted it, but we don't know if we've got it exactly right, so we're going to try and predict that. You do, however, know the volume of the sodium hydroxide is known because that's in the data table. right here. And you know the molarity of it because you calculated it in the previous question. So question 13 asks you, there you go, calculate the molarity of the sodium hydroxide. So when you finished working in this data table, your end result is going to be the result that you get from question 13. You're going to use that here in this titration here so that it's known. And then you know molarity times volume equals moles. And then if you know the number of moles of sodium hydroxide, you know the number of moles of vinegar. So however many I calculate here. Now, there's an issue here in that I don't give you the balanced equation, do I? So the first thing that you need to do is this question right here, number 15. Write the balanced chemical equation between sodium hydroxide and acetic acid. What's acetic acid? Well, you know what that is because you know how to name acids, right? We did that in Unit 11. So write out the formula for acetic acid and then predict the products of that reaction. And you should be able to do that because I gave you a few examples earlier in the document. So I showed you how it reacts with HCl and H2SO4. You should be able to predict the result. It's exactly the same type of reaction. But whatever that those coefficients are, so whatever these numbers are, you can then get the number of moles of vinegar, which you can then say, well, I know the volume that we used, we can figure out the molarity. And so you're doing the exact same process for the first titration in part B. All right. I believe that's really everything I have to tell you on this. The last few questions for analysis are just, hey, let's suppose I did a different titration. So here I'm doing the titration of phosphoric acid. Can you calculate the result of here are all the numbers? And sure you can, because you just did a bunch of these calculations. Number 21 we could have done in class yesterday. In fact, I think we might have. We did a similar question to this. So that is the titration lab. It looks a lot harder than it actually is, but don't leave this to the last minute on Tuesday night or heaven forbid, Wednesday night after you've taken the final and you're like, oh shit, I have to do lab number 5 now. Yeah, don't do that. Do this over the weekend. Do this tomorrow if you have time. Ask people for help in the chat. That's the whole reason that I give this assignment, is so that you have practice on Unit 16. I would personally do this before your exam on Friday. Or Thursday if you chose it on Thursday. Or Saturday or whatever. But, like, hang out with people in the chat and try and, like, work through it. And then ask me questions, because I'm here to help you with this, too. If you ask me any questions on the day of the exam, though, I can't answer it. Because I have to mute the Discord on Friday. But if you do this tomorrow and you're like, hey, I'm trying to do the titration, I don't know, type something in the chat and then help each other out. And then I will try and help you too if I see your question. Okay? All right. That is all I have for that lab. So what I'm going to do is I'm going to do... Oh, you know what I will do? Hold on. So save as... let's see here. Lab 5 lecture. I don't want to save it as a PDF. I want to save it as a PNG. All right, let's see how big this file is. Can I put this in Discord? Yes, I can. Okay, so we're going to go over here. We're going to go into 140, and we're going to go into that, and then boop. There you go. There's everything I just did is now in the Discord. So now you have this whole thing. So you can use this to help you in whatever way you want to. Because I really want you to be able to do this. Everybody kind of like just ignores this lab. Everybody just tells it to like piss off. I realized that like I only pasted the this is the second version of the picture, so the previous version I drew over, but you have the video at least to go with it. So so by itself it might not be super useful. In fact, let me write that in the chat here. So please use this to help with lab number 5. Be sure to watch the video. I overwrote some of the diagram in the middle in pink. There we go. Okay, so now you have all that information. That should help you. Which means now I can do this. Boop, it's gone forever. Goodbye. All right. So what I'm going to do now is I am going to go to this screen. And I'm going to start the 10-minute timer here. Whoa, that's not 10 minutes. I was using this timer yesterday to play a game, and that's how long it took us to finish the game. Us being a friend of mine and I. Oops, that was where we started the timer, so I got to change that. I stream video games with friends sometimes. There we go. I'm going to set the timer for 10 minutes, and when I come back, or let me be more clear here. During the 10-minute break, what I want you to do is if you have any questions, oops, we don't have this week. If you have any questions you'd like to go over for review, type them in the chat, and after 10 minutes is up, we will reconvene and I will answer those questions. If there aren't any questions, then we'll just call it a day. Okay, so go ahead and take your 10-minute break, and we'll see you in just a little bit. I'm gonna let the timer keep going for a little bit. If you have any questions that you'd like to put in the chat, please do so. I'm gonna check again in 5 more minutes, and if there's nothing, we'll call it a day. So see you in a bit. All right, we're back. Let me get rid of this music here for me. We'll come back to the music if we need to for to allow more time for us to collect questions. I need to go. I'm in like 6 other windows because I was talking to a friend in my other Discord. Let's see here. What do I want to start with? So, I think I did everything up here, yeah. So, Christian, let me know if that answered your question. And then Katie wanted number 4 on the Unit 13 worksheet. So, worksheets are in this folder. Actually, you know what? Let me open. Close current tab. Let me do the key instead. Oh no, what have I done? There we go. That's what I want. So I'm gonna just have the answer on the screen, which is fine. Number 4. And we don't need all of this out here. Oops, I'm sorry. I didn't mean to scroll that. Let me minimize that so I don't touch it anymore. And then pen. Okay. Sorry, there's something on my tablet, so I'm just like wiping it off with my thumb. Okay, so for number 4 here, so I have a compound that is 92.96, not 96, sorry, 26% carbon and 7.741% hydrogen. And I know that the molar mass is 104.15 grams per mole. Now, because this is unit 13, we can apply different techniques to it. So there's the mass percentage method, or we could just do the empirical formula method. Because I think unit 13 was empirical formulas. Might have been 14. I'll show you both methods if you'd like. So the first method is we're going to assume a 100-gram sample. So that means that I have this much carbon. Oh, these are 7s, sorry. And then we'll turn this into moles first. And so let's see here. 92.26 divided by 12.011. So I get 7 point... How many sig figs do I get? 4? 7.681. So I get that many moles of carbon. And if I do the same thing for hydrogen, then we can do... You'll notice that I get a number that's very, very similar, right? So when I make my formula here, I get C 7.681, H 7.680. We're going to divide by the smaller number, which really we're just going to get this. So there's my empirical formula, CH. And CH has an empirical mass, according to Lentech, of 13.02. empirical mass, because the formula that we got was this. So to figure out our multiplier, we're going to just divide these two. Whoop, we'll just do that. So 104.15 over 13.02. And lo and behold, the multiplier that we get is 8. So the empirical formula must be that, C8H8. Also known as cyclooctatetraene, which you probably have never heard of. I did some work with cyclooctatetraene, I believe. It is super, super explosive if you do a particular thing to it, which we did. We reduced it with 2 electrons. Okay, that was the first method to do this. Let's show you another method, which might actually be faster. But it does require a little more intuition here. So, again, we have 92.26% carbon. And then we have 7.741% hydrogen. What we're going to do is we're going to apply these percentages to our molar mass. I wrote the wrong number. So for carbon, I'm going to take 92.26% of that number. So let's do that. So 104.15 times 0.9226. And I get 96.08. Well, I guess we'll do 09 here. I'm going to write for carbon. And then down here, we'll do the same thing for hydrogen. And so we'll say 104.15 times 0.077 or 1. And I get 8.062 for hydrogen. And then what we're going to do is we're going to divide each of these by what a single one of these weighs, because these numbers are the weight for X carbons. And this is the weight for X hydrogens. Right? All the hydrogens in our sample have to weigh this. So if I divide by what a single carbon weighs, you'll notice that I get that. And if I divide by what a single hydrogen weighs, I get that. And then you can say, okay, there's my formula. Now, that's much faster to do, but is it as intuitive? Not really. This is what we were trying to do earlier in, I think, Unit 12, when I was giving you mass percentages, and I could say, like, a formula has 8 carbons in it and weighs this much and is this percentage. This is just a backwards application of that. So, there's number 4 done 2 different ways. I personally prefer this method much better because it makes more intuitive sense. And you can do it the same way every time. But you can also just apply mass percentages to it and get the answer. It's an online class, so do whatever the hell you want to that helps you, right? Like, you aren't beholden to one particular strategy over the other. I don't care. You can do whichever one you want. All right. I'm going to hit clear on all my work here. Gone forever. And we'll go to the next one. So, determine the empirical formula of a compound. Oh, wait, no, I skipped one. Sorry, I was skipping my own. So, a student wasn't able to message in chat. And so they asked me to do Unit 12, number 10. And let me find that. There we go. Let me just put that on the screen here. All right. In a 39.4 per kilogram sample of ammonium phosphate, what mass in kilograms is nitrogen? Okay. So first you got to know what ammonium phosphate is, and then spoiler. Well, that didn't work. Hold on. Spoiler, here's the formula. There's ammonium phosphate. And so I have 39.4 kilograms of this, which I'm just going to put into grams right away. And if I want to figure out how much of that is nitrogen, then we would do something like this. So I'd say mass to moles of ammonium phosphate. Sorry, ammonium. I should be more clear on that. And then we can figure out what part of that is nitrogen, and then we turn that into a mass of nitrogen as well. So let's get started. Let's get to work. Oh, my nose is super itchy. Very weird. I'm sitting here writing, and then my just like all of a sudden the inside of my nose is just like, ah, everything is itchy right now. Okay. So we're going to look up the molar mass of this on Lentech. NH4 3PO4, and I got 149.09. Where'd my cursor go? There it is. So this would tell me how many moles I have. And then we'll turn that into moles of nitrogen. How many nitrogens are in ammonium phosphate? Well, there's 1 per ammonium, and there's 3 ammonium, so that's a 3. So be careful with that. Don't just write 1, because I only have 1 nitrogen there. And then I can do this. A mole of nitrogen has some number of grams of nitrogen, and that's just on the periodic table. So when I do this calculation, I should get the mass of nitrogen in grams. Times 3 times 14.007 divided by 149.09 times 1 times 1. 11,105. But I only get 3 sig figs, so 11100 or 1.1. Oops, not 1. So 1, 2. Sorry, I can't do division. There you go. Is that what I was supposed to get? Yeah, there you go. I can do everything, but I get to the end and I can't divide by 1,000. Whoops. Oh, workbook. No, I did a problem for nothing. I have the workbook here. Actually, you know what? I have the workbook on here, too. Hold on. I could find that. Yeah, you're totally right. I flubbed that one up, didn't I? Who knows? Maybe it'll be the same problem. That would be really nice, right? Is that number 10? Yeah, that problem's way harder. I could see why you would want me to do that instead. Whoops. Okay. Well, I'm glad someone pointed that out because I wasn't paying attention. All right. A compound made from carbon and hydrogen is 85.6% carbon. If a sample of this compound contains 2.85 grams hydrogen, calculate the mass from carbon. All right, so we have, let's see here, so 85.6% carbon, which means that the remainder must be hydrogen, because that's what it says, right? So 100 minus 85.6. Now, remember that what a mass percentage says is the following. So that for every 100 grams of compound, I have this percentage of grams of hydrogen, right? And I could say the same thing up here. And so this problem is going to explore those relationships. So I know that my sample has this many grams of hydrogen in it. So how much compound would I have from the sample? Well, I could just do this, right? I could just take this relationship right here, and we'll just stick it right there. However, we got to flip it upside down so that the units match, right? So that times 100 over 14.4. That would be 8. So if I have 2.85 grams of hydrogen, I must have 19.8 grams of compound. And you can check this because you could say, okay, well, what is 14.4% of 19.8? If I go over here and I say, on my calculator, I say, okay, I want to take this number and multiply it by 0.144, I should get the 2.85 that I just started with. And you totally do. So now that you know how much compound you have, and you want the mass from carbon, now you just apply this to it. And so we'll do that down here. So 19.8 grams of compound. And there are 85.6 grams of carbon per 100 grams of compound. And so we get 19.8, 85.6, 100. So there must be that many grams of carbon in the sample. And I think I have the answer keys online for you, but here, if I just do this, so I actually don't look at Samita's key when she's doing this because I don't necessarily know what she's doing. She didn't write in all of our units there, but you can see a bunch of the numbers that we were using too, so. All right, so there's that one. Hopefully there aren't any other possibilities for Unit 12, number 10, because I sure can't think of any. But, okay, so we'll just scroll this one off the screen. All right, so determine the empirical formula of a compound that contains this mass of carbon, this number of moles of oxygen, and this many atoms of hydrogen. Who would give you this problem? Who did this to you? This is what I call a Samita problem. Because Samita likes to give the units in as much as obnoxious as possible. So she'll be like, determine the volume of a cube or of a rectangular prism if the edge is 31.5 miles and the length is 17.4 furlongs and the height is 397 billion nanometers of, I don't know, or something like that, where you just have this unit nightmare and it's just, convert everything to the correct unit. I'm going to interpret 1024 as this, because there's no way that it's times 1024. I'm assuming that was just copied and pasted, and the format doesn't know how to do that in Google, because Google is dumb. All right, so what we need to do here, remember, empirical formula, you got to turn everything into moles, right? So let's just do that first. So grams to moles. If you had Samita for Chem 140, she fills her exams with these things, and I can't be bothered. Like, I don't want to write the key for those problems. 2.658. I think it's great practice to have you guys do crazy unit problems that, like, Samita loves, but I'm just lazy. This one's already in moles, so I don't do anything. This one's not, but we can actually get there really easily. I mean, how many atoms are in a mole of anything, right? So, it's our favorite number. With the little X that I can't make appear. Typing this into the calculator is obnoxious. 1.372. I think it's this. Yeah, divided by... I hate that it does that. Can I just not... Can it not do this? Can it just tell me the... Oh, there we go. That's what I want. Divided by 6.022 times 10 to the 23. Now I have times 10 to the 0, so we... Oops. No, that's not what I wanted. There we go. So now I get 2.278. Yeah. And so there's our pseudo formula. So we would use this and that, which is already there, and that. So we'd say C, I superimpose the, or transpose the numbers. So let's fix that. 2.658. H 2.278. O 0.7594. We'll divide by the smallest number here. And I get, so 2.658 over 0.7594 is 3.5. That's good that it landed that close to a fraction. Oops. 2.278 over 0.7594 is probably 3, right? Yeah, 3. Uh-oh. Uh-oh. What happened? Why am I writing in... Why am I writing in highlighter? Hold on, I'm confused. What happened? Why is everything the worst? It's like my opacity went to like 0. But I totally didn't. Oh, it did. There we go. Okay, that's fine. Sorry, I have 2 places where there's opacity, and I guess typing in 20... Yeah, I totally did that, so if I just do that... Yeah, there we go. Okay. So H3. Just ignore the little gray scribbles. I know that's going to be obnoxious, but O is just O. I need to clear fractions. Clear fractions by multiplying by 2. And there's the empirical formula you should get. Okay, so there's the problem for Katie. Okay, and then worksheet. I want to make sure I do this right this time. Let's see here. Is this 14? That's 13. 14. There we go. No, that's wrong. Hold on. Sorry, that's the workbook. Worksheet. I knew I was going to fuck this up. Like, there's just so many things out there for me to ask you for questions from, and I want to make sure I get the right ones. So Brianna, let me know if this is the right problem. That I can't scroll this down any further, so I have to do this. So is this the question you wanted? Let me know. I mean, I'll just do it. And if it's wrong, then, oh no, I've wasted everyone's time. Ooh, I don't want to do that. Hold on. I almost deleted all the stuff in OBS. That would have been bad. Okay, cool. So we have barium phosphate. So we got barium, which makes this ion. And then phosphate, which makes this ion. And so to put those together, hopefully that makes sense. Why we would put those like that. I got to balance out the charges, and I need 3 of these guys and 2 of these guys. And then ammonium acetate. So here's ammonium. And then acetate. And that's easy to just put together. Can be synthesized, so what that means is these are the products. By combining barium acetate. So here's barium acetate. So and what are we mixing together? Ammonium phosphate. So the other 2 things here. Wow, I don't know why my tablet is really unhappy with all of this today. I didn't reboot the computer. I probably should have. But that's okay. And then do we have to balance this equation? Is it asking for a balanced equation? Then balance the equation you've written. All right, me. Oh, this isn't really an equation as written. So the problem asked us, it says can be synthesized. So these are our products. And then these are our reactants. So let's tidy up. And we'll write that as an actual equation. So barium I feel like it's doing weird shit because I hit a key or something, but okay. Barium acetate and ammonium phosphate. That's okay. We're almost done with the lecture. Make barium phosphate and ammonium acetate. And then now I have to balance the equation, and that should be pretty trivial. So this is going to get a 2. No, it's not. That's wrong. This is going to get a 2. This is going to get a 3. And then this gets a 6. There you go. So the way that these questions can be made tricky is that I can write can be synthesized by, and that is your cue to say, oh, those are products. Most of the questions won't do that, but like I try and like keep you on your toes. So just be mindful that if you see that, you don't want to accidentally write the products turn into the reactants, because that's not what happens. So. All right, we only have like 10 minutes left. Well, no, 20, sorry. I can't count, and I'm getting all my times mixed up. So I'm going to put the music on, and I'll wait 3 minutes or so, and if there's any more questions, go ahead and type them in the chat. But otherwise, we'll call it a day. So, sort of last call for questions, I guess we'll say. I just realized you could see me tapping away on the keyboard there. Because the calculator lights up. Oh well, whatever. Last call for questions. All right, I think that that's all the questions then. If nobody else has anything, we'll wind this array. And we'll head back over here. So, thanks to everybody for coming out to the review session. It's always good when there's participation in these things. If you have further questions that I didn't get to, or you didn't think of them in time, or whatever, type them in the Discord, and I'll try and get to them when I can. Your exam opens on Friday, unless you have specifically asked me for a different exam date. I will honor all of those up until 11:59 p.m. tonight, so make sure you get that in by tonight if you want your exam moved to either Thursday or Saturday. Once Thursday comes around, you have to take it on the day that you're currently signed up for. And if you haven't signed up for a new day, then it defaults to Friday. Exam number 2 is Units 9 through 16. There will be a review session next week on Monday. And then the final exam is Wednesday, and then that's it. We're all done. So thanks for sticking with it. Hope you enjoyed the quarter. Hope you picked up something useful from this class. And we'll see you in 161, right? All right. Good luck. We're all counting on you.